Do ba 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 do.
Welcome to the NMR lab. This is a strong magnetic field area. Please make sure you don't have any hard pacemaker or metal object with you. Are you NMR safe? Now we are going to start our NMR training. Every time before you go to the strong magnetic field area, please make sure you remove all your magnetic things, such as your card, handphone, watch, and wallet. Wallet is because that you have credit card or bank card inside. Then you can bring your sample and menu to the machine for training.
To launch the program, double-click on the icon. Press X followed by Close. Click once on d:\data. Using the tissue paper, clean the NMR tube. Insert into the spinner. Gently press down until it touches the bottom. Turn on the lift. Turn on the compressed air. Climb up and make sure that the gas is on. Put the sample in. Then turn off the lift. Now, let's begin with the analysis. The first one, we will key in dir to show all the data in the directory. From the list, all these files starting with std are the standard files. We are going to do the proton, so click on std1h to run a proton spectrum. Then click OK. The first one is a normal proton spectrum. Number 2, 3, and 4 are for water suppression. Now, we have opened the proton standard file. All the hardware and software setup come together with the software and standard file. Key in the command new to create new data. The file name should start with your initials, followed by the month, date. Then, set up your experiment number. Do not change the directory data. Make sure you select this Use Current Parameters. Then, you can select the solvent you use. You can drop down the list, select the solvent, and key in the title for the sample. After that, click OK. Now, you have generated an NMR data folder for your sample. Next, we are going to log the magnetic field. Key in the command log to log the sample. Here, we should select the right solvent. It is CdCl3 for this experiment, and then click OK. From here, you can see what the instrument is doing, and here you can see that the log is in progress. We just wait for the log to finish. Once logged, you will see the red light will be on for a while. Afterwards, it will turn green. This means that the sample is successfully logged. From here, you can also see log n: done. Log n: finished. Log n done means that the procedure is finished. Key in the command atma. This command automatically tunes and matches the probe to provide the right frequency for the experiment. For this sample, we are going to do proton analysis, so it will tune to proton channel only. During the atma, don't do anything else, just wait until it finishes. The nucleus tune here will be the proton. To have the best tuning and matching is to have this wobble curve being centered and it touches the bottom. After the tuning and matching, usually the window will store the data under ACQU. Click Spectrum to come back to your original window. You will see ATMA successfully finished, so we can proceed to the next step. Click on Spin to turn it on and the sample will start rotating. Now, the spin light is red. After a while, it will turn green. When it turns green, it means that the spinning rate has reached the targeted rate. Spinning improves the homogeneity of the sample. Now, we can do shimming. Key in the topshim command here. Topshim is shimming to homogenize the magnetic field. During shimming, it is normal to see the light on the log disappear. And once shimming is done, the light will be on again. We will just wait for the top shim to finish. From the information at the bottom here, we can see that the sampling is in progress. Here, we can see what the instrument is doing too. Now, the log light is red, and that means that the top shim is going to finish. Now it is green. Here you see log status. And after a while, it will be done. So you will see top shim : completed successfully here. You will see the same message here too. At this moment, our instrument is ready for the sample to do the proton analysis. The first parameter we need to check is the number of scans. If your sample is concentrated, you can set fewer number of scans. But if your sample is diluted, you can run more scans. To set the numbers of scans, key in the command ns. For proton, we usually start from 8 scans. Afterwards, click OK. Next step, key in the command RGA. We do RGA to automatically set up the receiver gain value. Wait for RGA to finish. Usually, it will just take a short while. When completed, the RGA finished command is shown here. Now, we can run the data. The command is zgefp. Zg is zero angle, while EFP is conduct Fourier transform. Under acquisition information, the file name, the number of scans, and the residual time are shown. Now, we wait for it to finish. If you wish to check that the data is in between the scans, use the command tr. Usually for proton, we don't need to do the tr. After a while, you can see saved 3 scans. Then, you can conduct EFP. This spectrum shown is for 3 scans. Wait for the 8 scans to finish. Now that the scans have finished, we are going to do phase correction of the peaks. There is a very good command called automatic phase correction, APK. After keying that command, all the peaks observed will turn out to be good. In case that the APK signal doesn't work and the peaks look like this, we can use manual phase correction. Just go to Process, then click Adjust Phase. You will see the phase correction mode. At this moment, a red line will appear on the screen. Click on 0 to use the 0 order to correct them. Press and hold the 0 button up or down with the mouse. Make sure that the baseline of each side of the peak is at the same level. Release the mouse once the baseline is level. 1 is the first order, and the first order is to adjust the other peaks. Once done, release the mouse and click Return and Save Phased Spectrum.sret. To see the full spectrum, click this button and the full spectrum will be shown. Click and drag to zoom in on the peak you wish to calibrate. Zoom in to make it clear triangle on the screen. Click Calibrate Frequency Axis manually, .cal. Now move the cursor and the line to the top of the peak and click. For this sample, we are using chloroform as the solvent. So type 7.26 and click OK. For this experiment, since we set 8 scans, all 8 scans have finished running. In the case where there are many scans running and you wish to stop in between the scans, type the command halt. Under the acquisition information, when the no acquisition running words appear, all the scans have been completed. To take out the sample, click Spin to turn it off, followed by clicking Lock to unlock the sample. Make sure there is no red light on both the lock and spin icons. Click Lift and proceed to take out the sample. Turn off the lift by clicking on it again once the sample has been taken out. Copy the data into this data shortcut folder. Look for your data. Right-click and copy. Now go to the target folder, R drive, which is the network drive. Double-click, right-click, and paste. You can now close the window and your NMR analysis is done. Voila!